Hey, I'm John Joswiak. I'm a solutions engineer here at GitHub. I've been at GitHub for about 2 years now, but used GitHub ever since it was created, basically. Brent, do you want to do a quick intro?
Yeah. Hi, everyone. My name is Brent Beer, Director of Solutions Engineering over here at GitHub. I've been at GitHub for just a little over 11 years now. So I've seen GitHub kind of from, very early days, just getting GitHub through using Actions, Advanced Security, and Copilot and beyond.
Excellent. So today we're going to walk through GitHub Advanced Security. I'm going to start just showing some slides and talking about the capabilities and the problem that we're trying to solve. And then I'm going to move on to that from that into a demo where I show how GitHub Advanced Security works and then how you can take and integrate that within your pipelines, whether that be Actions or other solutions. I'm particularly going to cover Jenkins and Azure DevOps in the demo. So why don't we get started? So how do we build today? So today, I see customers across a large range of security solutions or capabilities. I see customers who are at the early days where they're still doing code security scanning. At the very end, just before they're deploying, I see others who have it totally integrated within their pipeline, their process, and they're doing deployments to a public application on a regular basis. So I see a very wide range. And what I do see is that even the most mature customers still struggle, and the struggle becomes it's difficult to solve for the vulnerability. There's not a lot of context given within it. There's a lot of security risk, and we really need to still keep up. The speed of features that we need to release has only increased, and so. Generally, as security tools are being introduced, they're slowing down the developer. The developers get frustrated because they need to keep up that feature velocity. And if a security team mandates a solution, what I see is it causes resentment and friction between the two teams because the security team isn't thinking about the developers and their need to release software, and the developers aren't necessarily thinking about security. And even though, like, over the course of a number of years, I think that the knowledge of security, the knowledge of the need for security in applications has grown. I think teams are still struggling to be able to deliver. And so the last thing I
John,
would just say here, go ahead,
oh, I
Brent.
was just going to say, with all your time, in using GitHub, mainly especially in those early days as a developer and getting introduced to these, working with customers and everything else in your building experience, have you ever, and including today, have you, maybe a spicy take here, have you ever run into a scenario where there's not a little bit of friction between a development team and a security team?
I have seen some. I'm working with a customer right now who's working on implementing GitHub Advanced Security, and the the refreshing thing that I hear is that the security team knows that in order to meet their goals, in order to reduce risk, they need to enable the developer. They need to make the developer successful. So they're focused on ensuring that the developer has the least friction in the process possible. And what they're seeing out of that is it's making it easier for the developers to adopt tools and for them to come together and work together in order to essentially reduce the risk of the applications they deploy.
Yeah, awesome. It's good to see, things trending, starting to trend in the correct direction, right?
Yeah, and I do see, like, we also have, like, from a DevOps perspective, a wide range of DevOps customers. Like, smaller customers or startups, and even some larger customers empower developers to have full control over their pipeline. They develop the entire thing. They have full control of the tools that they select. And we have kind of on the other extreme, teams that mandate a pipeline, and every developer needs to use that same pipeline. So that also creates some potential friction, but in a different way. And that even if they wanted to use a different tool, or even if the process isn't working for them, they may not have the ability to edit their pipeline to make a change. So if we go back to what we consider AppSec 1.0, this is when security tooling was just starting. And what that workflow looked like is is, the security scan came at the end of the process as they were doing QA, as they were ready to release to production. And what happened is, developers get all their work done, they're moved on to something else, and a month later, the QA team comes back and says, hey, here's this stack of work that you need to do. Here's all these vulnerabilities. Of course, at that time, the developer hasn't looked at the code for quite a while and isn't up to speed on all the changes. So it takes them a long time to be able to do remediation at this point. And what we've seen a lot of customers in the marketplace over the last 2, 3, maybe even longer, have been talking about shifting left. The idea of don't do security at the end of the cycle, do security much earlier, integrate that into your development process, integrate that into your build process. And just like looking at this slide, it's much cheaper to remediate earlier than it is later, whether that be in Q&A, where you have all that time to get back up to speed on the code, whether that be in production, where now you need to release your application and those changes with a lot of testing, or whether that be in the worst case, having to pay millions from a breach. And so really we see customers wanting to get tools in the hands of the developer, getting the developers involved in that security process. And so I do see there is a shift from the security team owning security to the developers being a lot more responsible for their code and the security of that code. So we do still see 3 challenges even today that remain. One is false positives. We see a lot of customers struggling with false positives. I've been working with one customer who's using a tool. It scans their application and it comes out with roughly 28,000 vulnerabilities. And to be able to look through that number of vulnerabilities to see, is this a true positive? Is this a false positive? It's a ton of work, and most developers just don't have the time to be able to look through that quantity of vulnerabilities to make some sense of them. Another thing is most companies have lots of different tooling in the security space, and when the developer has to go to 5 or 6 different panes of glass to deal with security issues to be able to release their application, it's not productive, it's not efficient. It's very difficult for a developer to do that, to do that work. And then finally, we're seeing that like everybody knows security is a problem. Everybody knows we need to focus on this. We're seeing a lack of remediation. People are treading water with the release of their application. The backlog continues to grow, and it's a struggle for every developer and every security team as risk continues to increase. Brent, do you have any thoughts on that?
And yeah, in that lack of remediation, right? There's I have to get this out to market as soon as possible. I have to get something out there. I have to get an MVP out there. Oh, but there's vulnerabilities, right? From a developer perspective, I've often heard, yeah, it's fine. This isn't a serious one, right? The thought of trying to water it down to make it not so serious, and the security mindset, which is, well, you really can't look at it that way, right?
Yeah.
Is this reachable? Am I going to get to it? What's the full threat model of this, right? What's the surface area of hitting this? And then usually elevates to a level above the developer or the AppSec engineer, which is the directors or the VPs start arguing. And they start arguing that, oh, I have a mandate to move things further left. Well, I've done that, but now you're not helping me. And then the more of that friction comes in with, the false positives, or, oh, I forgot, I didn't know I needed to go into XYZ application to look at this. I'm already looking at my deployment and waiting for my deployment to go out to our UA environment or our testing environments. And I'm watching to make sure that deploy goes successfully. And those persistent problems continue to be there, right? Or if you have a large enough organization, as you mentioned, with multiple tools, maybe they're rolling things out and it takes a long time. They have one place where they're working on code. The developer wants the security team to be involved in that process, but the way that they're involved, like, kind of upsets them and frustrate them. Oh, I forgot, I need to go check this service, check that service, I'll mark this over here. And they just view it as additional administrative tasks, right?
Yeah.
So like, how can a developer continue to work and provide value and be that artist, that engineer, that creative to make their thing that they're excited to build without kind of being beaten with a stick, beaten or to tell them to fix things. I think it is an ongoing frustration that not a lot of people talk about, though they feel.
Yeah, and I think one interesting thing, you reminded me of a recent situation I had. I was working with a customer who's going through that remediation process, working with their security people on a false positive. Their particular security team doesn't have any application development experience. And so, as a developer trying to explain why they think this is a false positive to somebody who doesn't have a development background can be very challenging. And then as that escalates, you kind of get you kind of exponentially increase that, because somebody who's an engineering manager might not be developing day in day out, but at least they have the
Right.
context. Somebody who's a security manager or director may not have the context of the application either.
Well, and then what ends up happening is you get a lack of trust in the tooling. Different types of eroded trust in that tooling. Security team, may say, why are there false positives? A developer has the alert fatigue, right? Of how many alerts come up. Oh, we can ignore all of these. Let's change our policy to ignore most of these, right? And then the tiniest thing will slip through the crack, and the whole thing kind of crumbles, and you end up with potentially a breach or some situation, and you get on the phone with the GitHub account team and say, "Oh yeah, hey, I really want to take a look at this now." Oh, okay, did something happen? Oh, you probably can't tell us. Okay, got it.
So the next step of evolution is what we call application security 2.0. And really, this is where GitHub Advanced Security has fit in and introduced. It's really the approach of taking and focusing security tooling on the developer, with the developer in mind. So as you know, GitHub builds everything from the developer up. The developer is the core of our workflow. And that's the same idea with GitHub Advanced Security, is building a security tooling that meets the developer where they are. Now, we can't ignore the security team. The security team needs to be engaged. They have different needs than developer in terms of measuring risk, in terms of reporting, in terms of understanding where the application is at and ensuring that teams are taking action. But the focus, as we built, was specifically within the development lifecycle.
Yeah, I think that's an important thing to drive into that I've seen from our product direction, shift. I'll say within the last 2 years, give myself a wide window here, is, as we continue to talk to more security professionals and as we have them employed, and, at our own company, understanding the nuances of certain regulated industries, be it, healthcare, financial services, or within, government entities. How do they work? And we can't just blindly say the developer way, do this, change your entire business, right? There is a healthy amount of, I think, feedback through product roundtables and customer advisory boards and things like that to say, oh yeah, well, about this, let's start developing more of that security manager mindset or security persona to allow for the situations that have saved that customer in the past, be it a bypass rule or whatever it might be.
Yeah, definitely. And so we see security kind of taking a next evolution over the next year to two, maybe even 3 years. And really, it's artificial intelligence that's going to make a big change in this space. And so, from an advanced security perspective, we have some features there. From a GitHub Copilot perspective, we have some features there. The first thing is just using generative AI to help with code development. So, for example, using GitHub Copilot as you're developing, we have studies that prove that we get improved code quality as part of that development cycle. Copilot, for example, itself has filters that will filter out vulnerable suggestions. So you shouldn't be introducing these into your code base to start. So it's reducing overall the number of vulnerabilities entering. Now, it's not going to eliminate them, right? There's still going to be new vulnerabilities, but at least we're reducing that volume. And then when you do get a vulnerability, AI is going to be able to simplify incident response, whether that be by generating a fix in line with the pull request, whether that being able to ask with a chat interface how to fix or how to remediate, and getting really on-demand advice specific to your code base, rather than needing to reach out to documentation, to websites, to Google and query. And so really just having kind of we call it a pair programmer, but having somebody else to bounce a question off of and get a response to help with that remediation. And then more from a security perspective, being able to help build out queries to detect new vulnerabilities using generative AI, being able to help analyze patterns within secrets or within code bases, to identify secrets that otherwise have been very difficult to detect. Those are some areas that we just see the market changing. But as the capabilities improve with AI, the amount of things that it will be able to do in terms of remediation, in terms of preventing vulnerabilities entering the code base, is also going to continue to grow.
John, one thing I want to talk about here is that auto fix capability, right? As you're working as a developer, and to use the term lightly, the whoopsie daisy, right? I accidentally did something, right? Most vulnerabilities are accidents, right? They're maybe not.
Yep.
Well, from my experience, they're accidents. Someone accidentally did something. They're working with a new framework or a language, and they submitted something. And due to the complexities of multiple people contributing to something, that rush to market, that urgency to get that feature out, uh, and the lack of security engineers to review some of these things, right? You got like a 100-to-1 ratio, or at least maybe even a 10-to-1 ratio. You don't have enough security engineers to kind of go through this. That auto fix capability of being able to, as the developer is working in the pull request, to be able to, oh, here it is. Here's the information about what I accidentally did, and here's the suggested fix, right?
Yep.
But in that lies a very key word, the suggestion, right? It doesn't do it for you. It's not called GitHub Pilot, right? It's not called your new developer. It is your co-pilot to assist in what you're doing, to help things along, smooth things out. And it's up to ultimately the developer or people maintaining that feature, that pull request, to say, oh yeah, that does look good. But when that
Yeah.
happens, right, it doesn't automatically deploy. It's a part of the CI pipeline, as we're here talking today.
Yeah, exactly. And the idea for autofix is like most of the vulnerabilities that most, maybe all the vulnerabilities that we provide queries for with GitHub Advanced Security, we provide good examples of how to correct it. But it still takes a developer time to look at that code and say, all right, I see the example. Now I need to modify my code. Now I need to test that it works. What autofix is giving is it's saving that time rather than the developer needing to go through and do that analysis. They can look at the code, they understand code generally, they're coding, and so it's like giving you a solution in your language, in the construct of your code, that you just need to review and say, yeah, that looks good, or no, I want to edit this a little bit.
Perfect.
Cool. So with that said, I want to move on to the demo and really get hands-on. I'm going to start with showcasing the advanced security features, so walking through the product, and then I'm going to switch focus from there to how you enable it, how you integrate, how you use it, how you roll it out in your environment. So I'll start here. I've got a repository that we use for demos. This is just a Java bookstore application that we use. It's a basic application that we use to showcase the functionality of advanced security. And so the first thing that we have with advanced security is the concept of code security or code scanning. So this is static code analysis. And I've got a couple of pull requests that I wrote yesterday just to showcase this. Generally, a scan for an application this size takes a minute or two, but I don't really want to sit here waiting while I'm presenting. And so when I raise a pull request, this is what it looks like. I've got my pull request. It's running a number of GitHub actions to be able to automate things like build, test, and publish the package, to be able to do a deployment to Azure, and also run things like this code coverage report. But what the vulnerability looks like is this. So this is indicating, this is what pops up when you have a vulnerability. It will say, look, we found a potential problem in your code. It will show you the code in question, as well as a file in question, and it will give you the error here. So in this case, it's a SQL injection vulnerability. Now, a couple of interesting things here. You do get a good explanation of what that, or this is actually the auto fix. I'll show that in a minute. you do get a good explanation of this by clicking on Show More Details. So Show More Details will say, here's the CodeQL query that caught this. You can view the source of that query. If you want to, you can build your own queries yourself if you're of that mindset. But generally, the default set of queries works well for the majority of customers. And here's the type of information you get. So you get a good explanation of the vulnerability. You get a recommendation in terms of what to do to remediate that vulnerability, and you get example code. Here's bad code, and here's what good looks like. Here's how you can change that. In this case, by adding a prepared statement to this query. And so what this does for the developer is it says, great, I've got all my content here right in my pull request. I don't need to go to another system to review a vulnerability. I don't need to go out to the internet to do some analysis. I should have all the information right here, all the knowledge that I need to be able to go take action on this vulnerability. Now, there is more detail down here. We can get into the actual CWEs, for example. We can get into other references if we're so interested. I don't know. I'm going to read as little as I can to get the job done. And so coming back here, one more thing to show is this concept of show paths. So one thing that can be challenging in an application is to understand where the vulnerability comes in and where it can actually be exploited. And what CodeQL can do is it can show you that entire attack path from the source where the string is actually inserted all the way through your code base to where it could actually be exploited. So you can see that full code path, the number of steps it takes throughout your code base. Sometimes this can be really simple. It could be just a step, right? Other times it can be very complex and can be 20, 30, 40 steps, depending on the application itself. So now a developer has gotten this vulnerability. They need to take action. It's great that we have that content there. We have a good explanation of the vulnerability. We showcase exactly where it exists. We can show the path or the data flow that it takes. But also we want to provide a fix itself. And so in beta right now, we have AI autofix. And the capability here is essentially taking a look at the pull request, taking a look at the vulnerability, and then giving a suggestion back. So in this case, you can see the suggestion here. We have our vulnerable code, and AI autofix is suggesting use a prepared statement for this. Now, there's a few different approaches that I can take here as a developer. Like one, I can look at this code and say, yeah, it looks great, let's do it. If I want to do that, I can click here and just commit the fix. Now, what committing this fix will do is it will kick off another CodeQL run. So it will go through, scan the code again, assuming that's clear, you'll be able to take and merge this code. But maybe this isn't quite what you want, or maybe you want to add documentation or comments around this. You can also edit this code. So there's two different ways to do this. One is within code spaces. It's just our development environment within the cloud. You can launch a code space that will have this particular code. You can edit it, commit it, and then it will rerun your pipeline. The other thing you can do is just pull this down with the CLI locally, make the changes, and then commit. And then third, you could dismiss this if you want to. Maybe this fix isn't right. You could just dismiss it and then take on the vulnerability yourself. So that is code scanning. The idea here is that we catch the vulnerability early as you've committed code, as you've recently written the code. And so you have the full context of what you're doing and details to fix the problem right here within GitHub. And hopefully the fix is provided for you and you just need to commit it.
Now, John, if that fix is there and it does look like it's going to work, how sure are you it's going to work? So I'm trying to not lead the witness here on the next step, but you committed, and then what?
So we have seen from our own testing a high percentage of success. That said, like all things, like this isn't AI writing the code for you. It is an easy button, but it still needs you to review that code. It still needs to go through your CI process again to make certain that code does fix the vulnerability and doesn't break anything out.
Yeah, it's not commit and merge, right? It's
Yeah.
It's just like another developer coming in here and being like, oh, actually, I fixed this, right?
Yeah.
Saying, oh, there's the commit. Now we go back through our regularly scheduled process of running CI and making sure it builds, right?
Exactly. Exactly. So I want to point out just one more thing on the code security space before I move on. And that is just all of your vulnerabilities. So here we've got a number of vulnerabilities within code scanning. And you can see a number of different severities for those. I want to call it two things. The first thing is in your pull request, you will get blocked only for new vulnerabilities you're introducing. So if you've got 38 other vulnerabilities in your application pre-existing, you're not going to block that pull request for those 38. Do you need to address those at some point? Sure, but it's not relevant to the developer, to the code that they're just writing. So that's one thing that I wanted to point out. The other thing I wanted to point out is we have an integration capability with other tooling. So any tooling that exports in Serif, which is an industry standard format, we can pull in here. So you see, for example, here, this vulnerability is detected by Gripe. The Gripe is a container scanning solution. We don't have a native container scanning offering, so we can pull that detail in. And in fact, just from a tooling perspective, I will call it the Gripe X here is simply because we have vulnerabilities at the moment with Gripe. But I wanted to call out here, there are many different tools that we can integrate with. And so if you think about it, if you've got other tooling, for example, DAST, which we don't do, you can integrate that tooling here, get the results shown directly here versus having the developer have to go out to another window. So just another way to say, like, yeah, even if you have to maintain other security tools, let's make it easy for the developer by getting all of their information into one place.
Well, and make it easy for, that remediation, right? That information
Yeah.
gathering, all of it being in one place. John, earlier we mentioned these three kind of problems. The alert fatigue, still there. But, as you're doing this context switching, because you're at a large company or you're at a mid-sized company, it doesn't matter. You're at a company with more than one security tool. Don't make the developer go to these other places. Developers live in this world. Pull things into their world that
Yeah.
can be pulled into the world. If you're doing a rollout or you've got one team that's bought this tool and another team that's bought that tool, but you're trying to implement both of them in a new solution, it's like, well, okay, cool. Great. We have all these partners that GitHub continues to work with that allows us to get their information out over to our tool. Now, of course, you can't do the analysis or you can't do, I think it's the upload Serif step unless there is an advanced security license available, right? But as you're thinking of not just today, tomorrow, but next year and beyond, what is your plan for getting to a given point? Being able to use these tools together, even though they're at conflict with one another, right? They're competitors, right? It doesn't matter because the end goal is achieving this clean state, right? Staying clean, from this point forward, and then getting clean, maybe working on those older vulnerabilities that continue to exist, but certainly not introducing any new ones, right? Allow the
Yeah.
developers to be in this kind of healthy mind state of, okay, new things are coming in, I'm able to block them, nothing new coming in on what we're building and working on.
Yeah, definitely. Definitely. So I want to move on from code scanning now and focus on secret scanning next. So the idea behind secret scanning is two things. So first of all, identifying secrets within your code base in a very simple manner. So when you turn on secret scanning, it will scan your commit history. It will scan all of your repos, your issues, your pull request comments. I think we recently introduced wikis and we're working on discussions to be able to identify secrets within your code base. And when you identify a secret, in this case, a Google API key, this is what it looks like. So you see, I've got a secret. Now, we try to detect whether a secret's active or not to save people time, right? If we can detect that this secret's inactive, you can look at this quickly and say, that's inactive, it's not a risk. I can close this, it's already been fixed, it's already been revoked, right? However, we can't do that for every secret pattern as of yet. And there's a simple reason for that. Like, we don't want to just take this secret and hit that provider's endpoint. That's kind of abusing the secret. And so we're working with partners to say, all right, we've detected this secret. how can we test it to determine whether it's active or not? And as we work through that, the intent is that we get that with all partners, where we can detect that and simplify for people doing this analysis to say, yeah, the secret just isn't active. We can just dismiss this. But so this is ideally focused on like your entire code base as it stands now. We also want to prevent new secrets coming into your code base. And so for that, we have a capability called push protection. And my code space stopped. All right, I'm going to restart.
And while that's happening, John, one thing I want people to think about is if you're working on a feature or a new app and you have environment variables that you're working with, right, in order to deploy it or something else, and you're just testing them, right, and you want to push the work and you're rapidly developing and things are going very fast, are these caught? Is it good to catch those at build time? Or from a CI and developer perspective, what's the thought on secrets here now that everything's up? If you can quickly
so
mention
the thought is it's a pain to clean out your commit history. It is a pain. And so the thought is prevent that from getting into the history, prevent that from getting into your repo altogether. So here I've got just this sample Java app. I'm going to go in and just add a vulnerability. So let me check out secrets. Check out a new branch, and I'm going to take a secret here. Actually, I don't know why I'm looking at the pom.xml. I'm thinking of dependencies. I'm going to go ahead and add another secret. In this case, the previous secret's just in a test file here. I'm going to add another secret. It's just an AWS access and secret key. So I can do that. See my status. I can add that. I love secrets. All right, let's push that. And I always forget that. So let me paste that there. And this is what the developer will see. So when the developer pushes, they'll see a GitHub push protection error saying they can't push this secret. It will call out, here's the file and the commit and the specific line number of that secret. Now, there's a couple things that are of interest here. The first thing is we have the ability to show a secret handling policy. So if you're a security engineer and if a secret is pushed here, you want to have your policy front and center to say, all right, developer, here's the steps that you should take. If there's steps to remove this commit, great, let's provide those steps right there. If there's a exception policy that the developer should know about, great, we have that right there. But ultimately, we don't want to get in the way of the developer. So today, a developer can take this and basically override this. So if they really need to get this secret into the repo for some reason, I can't think of a reason why, but if they need to, they do have the ability to override. Now, I know we're working on a feature from a security perspective to say, all right, we don't want to do that. Can we have a review process built in so that a security person has to do that override and provides an easy way for that to happen, where the developer gets in front of a security person quickly, can review the secret and make a decision on what to do.
Well, and to relate this back to that whole CI build process, right? If you're sitting there waiting for your builds, or your builds are going to take a while, like you need to push this out and you need to have someone review it, right? There's a question that came up in the chat too, just about the exposure of, even if it's an internal repo, right? Like even if it's hitting the internal repo, it's private, you don't know about inside threat actors, you don't know about compromised accounts, things like that. So that is the flexibility and the difficulty with some of these bypasses, right? Allowing this to be pushed through with notification. Well, it's like, what frame of time are we really comfortable with here? And again, all because we want the developer friction to be as low as possible while minimizing or removing any amount of security threat.
Yeah, definitely. So that's really secret scanning. It's pretty simple, but it's really effective. And the one thing I didn't mention, we're really focused on partner secrets. So I think we've got 130 plus secret patterns. That number changes a lot. When I started 2 years ago at GitHub, I think it was at around 100 and continues to grow. But you also have the ability to create custom secret patterns of your own. We, as an advanced security organization, have a lot of patterns defined. So for example, things like MySQL connection strings, we can build those in as custom patterns. If those are important to you, you can also build your own patterns specific to your company's secrets. And then a last thing I'll add there is that we're working in beta with AI to do custom secret detection, to be able to simplify the need for patterns, but also provide a high fidelity, low false positive rate to be able to detect just high entropy strings and patterns that otherwise are secrets that are a little bit difficult to detect with regex.
Yeah, so John, being aware of time, I think a switch over to some of the kind of configuration, right? Like, this is the experience, this is what it's like, but how do I get there, right? What is the the first, next, and et cetera, from enabling this from a developer perspective?
Yeah,
from an organization perspective, right?
That is a great call out. Let's transition over to that. So the first thing I wanted to show is kind of at a repo level. So I've got a new, essentially blank repo here. I have a React app that I'm going to push into this repo just to show the code scanning process. But what I want to show is at this at the repo level, we have code security and analysis settings. So I didn't touch in my overview on Dependabot. Dependabot is a capability to find like software composition analysis, find vulnerabilities in your third-party dependencies and alert on them. So enabling that here is like a one-click button enabling security updates where we raise pull requests to solve those vulnerability issues is a one-click setup. For code scanning, it can be. It's a little bit, it depends. So here you see code scanning with CodeQL analysis. I've got two options here. I've got a default option and an advanced option. When I click default, this is going to scan the repository to understand what languages are in the repository. And it's going to create a GitHub action workflow that solves or that scans this repository. And it's going to set those scans on for push and pull requests to main and protected branches, and also scan on a weekly schedule. The reason weekly is, let's say you have an application that is a legacy application. It doesn't build very often. You still want to detect if there's net new vulnerabilities in that code over time. And so that's why we also do a scheduled scan. So if I click enable, this will enable this, and it will kick off its first scan. Now, I'm not going to do that right now because there's no code in this repository, but I also want to show the advanced setup. So with the advanced setup, what you'll do is you'll click this advanced button, and it's going to create a YAML file based on what's in your repository for you to check into that repository. Now, I'm going to show you that YAML file in a moment, rather than right now, as I go through and show you CodeQL and how it functions. The other things to note, you can set a threshold for that pull request. So here, high and higher is our default threshold, which will mean like if you create a pull request and it has a code scanning vulnerability, it's going to block on a higher vulnerability.
And John, I think what's important about that too is the rollout, right? If you're just implementing CodeQL and you want to start informing the developers first, hey, by the way, you're submitting these pull requests with a high or critical vulnerability, that's good. Maybe you're not ready to block them on it yet, right? You're rolling this out slowly, and you just want people to be informed about the integration. So that's really great to do there.
Yeah, and then secret scanning, again, one-click push, one click to enable, one click to enable push protection. Very straightforward to deploy. I mentioned the custom patterns before. Here's where you would create one at the repo level, at the organization level, and I think at the enterprise level now. I'm 90% certain on that, but I think so. All right, so going to my application, I've got this sample node application. It's just a very simple React app. It has the ability to add like a question mark name equals and pull up that person's GitHub profile by calling out to the GitHub API. And so what I'm going to show here is just the CLI and how the CLI works for scanning. Now, I had this done yesterday just because I don't want to waste our time watching you watch a scan. It's not fun. It's not something that I would normally watch. And I don't think that you probably appreciate that. But I want you to see what it does. So here is, let's see, starting up here. All right. So here is essentially the commands, and I'll talk through this. So CodeQL has a CLI. CodeQL is the underlying technology that powers code scanning. And so you have the ability to scan on your own machine. But why I show you this is some people do that, but the bulk of people are scanning within their CI system. To scan in a CI system that isn't Actions, so let's say Jenkins or Azure pipelines, you're essentially using the CLI to enable that. And so there's a couple of steps for the CLI. The first one is this CodeQL database create, or there's also a database init. They're subtly different. What CodeQL database create does is it's going to create a database of your code. I've specified the language here, in this case, JavaScript, and my source, which is just my root directory. Now, what it's doing is it goes through here, extracts all the code, and puts that in a database for CodeQL to then analyze. So essentially, it's creating a custom database of your code, of your data flow for use in analysis. So this takes roughly a minute for it to execute against this code base. The amount of time it takes to scan varies widely. Basically, it varies depending on the amount of code in your code base, the complexity of that code, as well as the size of the machine that you're using to scan. Like I've got a MacBook here. It can probably handle some reasonable sized code, but as you get into very, very large code bases, you would want a bigger machine than my laptop to do the scanning.
Well, and if those code bases are in different languages and you wanted to do a scan per different language, right, which we'll see in the Actions, or you can see, in a Jenkins file example, you want to specify that source root differently for those different languages, and you specify the language differently for those languages, so that you're controlling, what files it's looking at and how long that might take as well. And you might want to break the build on certain files being scanned and have different query packs and customization. Which
exactly.
Don't want to get too ahead of ourselves there, but
yeah. And so the next step after that is just this database analyze step. So what database analyze is doing is it's actually taking all of the queries that you have from CodeQL and running those against the database to basically see, are there vulnerabilities in this code? And so you see here, CodeQL database analyze, I've just got the directory of my database itself. My output is going to be in serif format. The category is JavaScript, it's JavaScript code. And I'm outputting just my local file system, calling this demo app serif. And so you'll see this run through. Again, I think this took like a minute for it to execute. I didn't want to sit here watching this execute during the demo. And so I showed here, there is one last command that you tend to use as part of CI/CD pipeline, and that is uploading the results back to GitHub. So right here, these results, the findings that it has, aren't shared anywhere. But generally, running it in the pipeline, you're also uploading that serif result back to GitHub, so you can report on that within the GitHub web interface. And so what this looks like, if I move that out of the way, what this looks like is here. This is the code base. I've got this demo file here. And so when I click on it, I'm using, yeah, that's fine. I'm using a serif viewer, which is just an extension within VS Code. And I can see here the vulnerability that's found. It's found a cross-site scripting vulnerability. I can click on that. It'll bring me to the code where this vulnerability is. And so I can select this code. Generally, I'd see the whole code on my screen, but I kind of got it a little bit wider in order to be able to display fine for this demo. And so here, maybe I need to make it a little bit.
And John, this is kind of perfect timing, because there was a question earlier about seeing the CodeQL scan kind of in your editor, and I was going to maybe try to lead you on why you don't necessarily. Maybe you might not want to see that. Might not want to wait for a full build locally, but herein lies why you might run these commands locally.
Yeah, there's a couple of things there. So first of all, I'm showing you like creating a serif output here, running a scan locally, and
right.
being able to look at those results. There's also another extension that you can use to pull like the alerts out of GitHub, so you can look at the code scanning alerts in Visual Studio Code here, just exported from there. The thing is, like, if you have something that's scanning as you're writing, one, it can't see the full flow of the application as part of that. And so you're bound to get a lot more false positives alerts. And also, generally, as you're writing code, you don't like being interrupted constantly. and so we've just found from talking with other customers who've used security tooling within the IDE, they haven't adopted it well. They haven't found it significantly useful. They find it more distracting.
Right.
So the other thing I want to show here is that, with if you're not familiar with GitHub Copilot, with the chat interface, I can just select this code and say, can you help fix the vulnerability in the selected code? And so Copilot will come back and explain, yes, it will verify, yes, there's a vulnerability in this code. It will also give me code to fix that. Now, I can look at this and say, all right, that's fine. I could carry on this conversation if it didn't quite meet my needs, or I can just click this button and accept the code. Now, I'm not going to do that because this is just a demo. However, it's provided the fix. I can go back through, run a second scan, verify that it's working. I can test my application myself to verify it's functional. This is what we're talking about with AI being able to expedite the process of solving this. Now, this isn't a particularly challenging vulnerability, but still it would take me time to figure out, what exactly do I need to add and go in and add it. So trying to make that simple for the developer. So what I want to do next is just take this app. I've got a separate repo here, and I'm just going to push this application. So I've gone through, let's say I've written this application, I've added it, I've committed my initial app, and I'm going to do a git push to my repo. And so that's kind of like the really brief, abbreviated version of the developer writing something, right? But once they do that, what you'll see here, if I go back to my code, is one, I should see, create my pull request. Awesome. My quick PR. And let me create my pull request. And
John, I can attest that normally you write proper description statements. So, don't worry. Everyone here is not going to be judging you here on that.
And so what you'll see here is in the actions pipeline, this is starting a scan of this application. And so if I go over, like I mentioned that there's the default, let me pull it up here. It might show better. I mentioned that there's the default way to scan, but there's also the ability to create your own CodeQL workflow. And this is what that workflow file looks like. And so if you're familiar with actions, this isn't significantly different than any other actions workflow. But what this is it's saying, its triggers are a workflow.
John, just to interrupt you, can you change this to not be side by side with the three dots there on the far right?
Yeah.
There we go.
There you go. Yeah. So basically, these are your triggers. So on manual trigger, on push or on pull request to main, as well as on a scheduled event, run this workflow. And the workflow consists of roughly what you've seen from the command line, only we've got first person, like native GitHub actions to do this. So we have an analyze job here. We're specifying the permissions of that job. And then we're going through and doing a scan. Now, I did a database create previously. We have a database init step. Normally, what the init step does is just initialize a blank database. However, in our action here, it's kind of a mix of init and create on the command line. If it's a language that's interpreted, like JavaScript, I don't need to wait for a build. I can initialize a blank database, and it will scan the code and import it. For applications like Java, C++, C#, where you do need a build, essentially what CodeQL init does is prepare CodeQL, and then it will trace your build and then do an execution based on that. So I've left auto build in here just as an example of that. Auto build is going to look at Java and ignore it, or JavaScript, sorry, We're also iterating here a bit. So particularly in Java and C#, we've introduced a capability called build-list scanning. The idea here is that generally to instrument a build takes a bit of effort. It's not as straightforward. It's not one click, and people have kind of had some, I don't know, struggles at time with getting that to work. We've done a lot of engineering work testing build lists for those languages, and have found that we can get nearly the same fidelity in terms of alerts and in terms of quality of alerts through a build list scan for those languages. And so that's in beta right now, where you won't even need to build those languages. It just simplifies this quite a bit. C and C++, we find still so much can happen in the compilation that we get widely different results if we were to use a build list style approach. So besides that, the initial init of the database, the build process, whatever your code build is, actually doing that build, CodeQL will monitor that to understand data flow, and then the analysis step, which is actually taking and looking at that database that we built and pulling out, executing the queries against that and pulling out the results. And so,
John, a good question from the chat, right? Like a code scan we talked about this earlier. A code scan can take a long time, right? But is it a good idea to scan each commit or only run at time of PR? Can you specifically on the top part of the actions file here, right? Like how do you scan? How do you see others scan for the developer experience, right? Because we're wanting security and developer experience to kind of get along here.
Yeah, I guess a little bit of this goes to development best practice, and a little bit goes to what makes sense from a scanning perspective. When I'm writing code, I generally have a lot of commits, and then I get something that's ready for other people to actually look at. It becomes a pull request, and it gets merged in. Sometimes those commits are, I'm troubleshooting this. I need to add something to my code and go through and build. In the example of if I'm writing a GitHub action, for example, where I need to test it within the action system. And so normally I don't just have one commit for a chunk of code change. Normally my commit is smaller, and I don't want to sit there and spend a lot of time scanning for that one commit. Normally I find that at the pull request, I finally got something that's near ready to be used for other people to look at, for other people to review. And that's the time that I'm ready for a scan. Now, on a small application, yes, you could scan as often as a commit. I don't see people doing that. I see people normally scanning at a pull request or something that's that size before getting it merged in.
Yeah, and John, so about build list scans, do you still need a workflow file here? Can you use the default scan for like a Java project, for instance?
That's a good question. I don't remember off the top of my head. I don't know if you do. I'm pretty certain that you can do that in default. I'm just not 100% certain.
Yeah, I'm kind of at the same page as you. There was a question from the chat. It says, when is build list scan coming, right? Like we have it for Java, we have it for C#.
Mm-hmm.
Gosh, not to leak the roadmap, but I think Ruby and Go are either out or about to be, in beta and things like that. So working on those with C and C++, these are all things that are coming on top of those build list scan, right? But that may require that you go into the repository and go under that code scanning step and say, oh, I do want to do it in advanced. And then it'll prompt you on creating that workflow file. And if some of those build list scans fail, what that might mean is your repository needs that build step. I don't know if you can scroll down a little bit here in this particular, I know this is a simple application, but as you have that build step in the scan, instead of saying auto build, right? That's the part of your CI process where however you're building, you would just implement it there, right? So there's numerous examples out there to give you an idea of, I'm new to this and I need to implement this. How do I do this in actions, right? Now, if you have Copilot, something I haven't verified, but something fun to try is to have Copilot do that for you, right? In the context of your Visual Studio Code, Visual Studio, Vim, or wherever it is, or if you're using, Copilot Enterprise, you could, prompt it and set it up in the right way to say, hey, explain how everyone else in my organization is building their Java, C#, Go projects.
Definitely. So I want to transition to one other thing real quick and then get into Jenkins and Azure pipelines. I know we've only got a few minutes left. So what I want to show you is just in our Octodemo repo, I want to show you at an organization level what a rollout looks like. So not Copilot, I do talk about that a lot, but we've created this a capability called code security configurations. And this is kind of a change from our previous experience. So we started with, you had to touch every repository to enable, and customers were like, wow, I've got a lot of repositories. That's a lot of things I have to do. And so we kind of heard that feedback, and we took our first iteration at this, and we have an enterprise level and organization level ability to just say, auto turn on everything, like one click, turn on secret scanning. And that works great because you can enforce secret scanning and push protection the day you buy GitHub Advanced Security with one click. Or on the Dependabot side and dependency review, I didn't touch on that. I ran out of time there, but really for your third-party dependencies, you can also turn that on with one click for dependency alerts and see those within Dependabot across your entire environment. For many of our customers, when you looked at code scanning for that, it's like, yes, it's nice if we could do that, but generally, if you've got many different teams, not all the teams are going to be able to adopt a new code scanning tool at the same time, even if the rollout was as easy as clicking a button. And so what we've changed is we've created this code security configurations capability. And the idea here is that you can create a configuration and say, here's the things that I want to be enabled for this group of repositories. And then I can say, here are the repositories that I apply this to. And so it just gives you a simpler way to be able to target and roll out, say, by team basis, versus having to say like, yes, turn it on for everybody. We still get that same easy implementation. However, we get it at a more fine-grained level to be able to say, in these groups, let's do this implementation. And then
yeah, and as of even a week ago, adding the code scanning option for the repository rules. You don't have to go into it now, but just to mention it here for everyone is, being in public beta, that the code scanning can create those dedicated code scanning rules to block pull requests across the organization. So it's not just on a repo by repo basis, configuring it here and saying like, okay, I'm setting up code scanning rules everywhere, as we see here. There we go. I'm trying to save you some time, but yeah, being able to target the branches, have the repository rule set, and then specify the rules and the tool specifically if you are using any of those external tools.
Yeah, exactly. So in this case, CodeQL as a scanning tool.
There it is.
Yeah, and it's just a simpler way to be able to enforce across a number of repositories and try to make the rollout and adoption as easy as possible. So the last two things I want to talk about, I know we're at time, but I think I can go a couple minutes longer. It's just in terms of how you integrate this into a third-party CI/CD system. So in this case, Jenkins is built with Jenkins files, and so you're really relying on the CLI. And so there's a little bit of uniqueness for each CI/CD system in terms of the type of information it presents, the way you create build steps. And so I just wanted to show here, and obviously we need a checkout step to check out our repo. In Jenkins, one of the unique things is it doesn't provide you the right commit data for your change, the right ref for the commit that you need to be able to upload results. And so you need to do a little bit of work there to provide that detail. Customers may already have this. Like most people aren't running a single Jenkins file. Most customers have large shared libraries of functions that their DevOps teams use. In my case, I'm setting up some prerequisites here. That CodeQL bundle, the CLI, I need to install it here. I can install it on the agent itself, or I can install it as part of my workflow. Gripe, which I'm using for container scanning, yes, I would install that there, right? Dependency review, I'll skip over. But the build steps are just like the build steps that I showed on the command line, with some subtle differences because I'm doing a different language here. So in this case, I've got my CodeQL database init, which is creating a blank database for Java. And this is beginning tracing. So I'm doing what's called indirect build tracing, which means that you can use your own build step for Java and just wrap it with CodeQL. And so in this case, my build step isn't super exciting. But in other languages like C and C++, it can be quite complex. and it's difficult to have CodeQL just replace that, right? So here we're going to trace that. Once we're done with the build steps, we're finalizing that database. I'm doing the analysis step here. So in this case, my analysis is choosing this Java security and quality security pack or query pack, which has more in-depth queries, but basically doing the same thing, outputting my Serif file, and then uploading those results to GitHub so that you see those within your pull request, within your pull request as a check, and can block a pull request based on a vulnerability, just like you do with a GitHub Actions workflow. And it's very similar here with an Azure pipeline. It's the same type of thing. Now, I should mention, like, if your repos are in Azure, we have GitHub Advanced Security for Azure DevOps. That's the right solution for that. But if your repos are sitting in GitHub, many customers will first migrate their repos and then later modernize their pipelines. And so oftentimes we have customers who have Azure pipelines tied to GitHub repos. You can do a similar thing here. Download the CodeQL CLI, create the database, just like I did at command line. I can do an npm run and build here, just for example. It's not needed for CodeQL scanning. And then do that database analysis, and of course upload the results. Now, like all these steps here, they can be done as part of a large pipeline. You can have your build, test, publish, and you can have this around that. You can also have this as a separate workflow. So if you're a customer who's got your repos already in GitHub, even if you're using Jenkins or Azure pipelines, if you want to eventually get to actions, an easy first step is just use the default, or advanced CodeQL action and do your CodeQL scanning just from actions, and it simplifies the deployment. You don't need to use the CLI. And
John, on that note too, there's a question that came in about kind of when to do the scan, right? When to use gas to do the scan? At what point? Like in this particular one, they're using NuGet Artifactory, and that's on ADO. So at what part in the build scan? I think you kind of touched on it just now, but more explicitly, when as a developer, do you want that scan to happen, and what's the experience you want that to be like?
Yeah, I mean, generally, I want the scan to happen as I push code and raise a pull request or a merge request. At the time that other people are seeing the code that I prepare, but still at the time where it's recent.
Does it have to block the push to Artifactory? I mean, I think
yes.
That's maybe more of the question. I'm keeping an eye on chat.
Ideally, yes, but there's a bigger question there in my eyes, and that's how you handle the Artifactory side of things, right? I know customers who have Artifactory and they have kind of like an unverified and a verified release branch within Artifactory, if you will.
Right.
And so they can build as much as they want unverified, as long as they have some process to say, all right, none of these unverified pieces of code can ever get into a verified pipeline, right? None of these can be deployed if they have a vulnerability, or if they have a vulnerability at a set level.
Right, exactly. Awesome.
Cool. Well, that's all I had. I rushed through a little bit there, I think, but I wanted to show the capabilities of GitHub Advanced Security, the ability to code scanning, introduce that within CI and CD, the ability to have secret scanning and really prevent secrets from getting into your code base. And so kind of prior to the CI stage. And I didn't have the chance, but Dependabot and the ability to identify third-party dependencies and capture those as vulnerabilities exist and get those raised as a pull request, or getting those blocked within your CI system with dependency review. Anything to add, Brent?
Well, and just one last thing. As part of the follow-up, we'll be including a lot of resources and links as part of this. I know there was a question very early on about the slide deck. I think, John, you and I will double check through that to see if we're cool to send that. Maybe take out speaker notes. Including the thing about the dependency review and just doubling down on some of this documentation on how people can get started, I think is going to be very important for people to take, not look at the end goal, but not try to jump there right away. But, what is the first incremental thing we can start doing to, reduce that friction between the security teams, security and development teams, to ultimately just, do what we want to do, which is write secure code to the benefit of our customers. So,
Awesome. Well,
well,
thank you. Thank you very much,
well, thank you.
everybody. Yeah, thank you.